Hey everybody, I'm here today to give you a demonstration of Le Chatelier's principle. I have two containers here. They're both equivalent. They both have the same amount of water in them. It may be difficult to see that, so I'm going to put a little bit of food coloring in here. All right, so let's put a little bit of blue into the one that's labeled reactants. Okay, so we have our two containers. They're both full of water. They are connected by a tube, and the tube is full of water as well. And as you can see, one is labeled reactants and one is labeled as products. Le Chatelier's principle says if the dynamic equilibrium is disturbed, the system will shift to counteract that disturbance. If something is changed, the system is going to shift in a way to sort of nullify or cancel out that change. So I'm going to stir this up a little bit because I'm impatient and I don't feel like waiting for diffusion to do this. Okay, so now you can see that the reactants are clearly colored blue. So right now the system is in equilibrium. Some of the water is moving from the reactants into the products. Some of the water is moving from the products into the reactants. It's happening kind of slowly, so I'm going to speed it up. What would happen if I took out some of the products? So let's say I have a chemical reaction happening and I remove some of the products from the system. As you can see, the system is shifting. It is now producing more of the products. More of the reactants are changing, and they are changing into products. Let's shift it more. Again, I'm a little impatient here. Okay, so you can see that we have had a shift from the reactants to the products. I took water out of the product side, and some of the water from the reactant side shifted over until both beakers, or both of the very large containers, the very large beakers, now have the same volume in them. Okay, well, what happens if I add something to the products? Before I subtracted, I took away products. Now I'm going to add products. And if you can see the color in the tube changing, some of the clear water from the products is now pushing over to the reactant side. So some of the products went through the reverse reaction to form the reactants. I took out some of the products before. How about if I take out some of the reactants now? Okay, so hopefully you can see that all of the liquid in the tube is clear now. Some of the clear products have shifted through the tube to create more of the reactants. And my sign fell over because it got wet. This is a little bit messy. Sorry about that. All right, so when we take reactants out, the system goes through the reverse reaction to make more reactants. So we have fewer products than we had before. What if we add reactants? Again, the system is going to shift, and it will go through the forward reaction, and we will have fewer reactants, and we will make more products. No matter what we do, the system shifts to remain in equilibrium. All right, we'll do this one more time. If I take out reactants, we have the reverse reaction happening. If I take out reactants, the reverse reaction happens, we make more reactants, we have fewer products. What if I add reactants? Now the forward reaction happens. We produce more products. We're going to have less reactants because it's producing more products. Maybe you can see the water level in the reactants was dropping. I think it's equalized now. Okay? So if I remove reactants, I have less products. If I add reactants, it makes more products. Well, what if I work with the products? Let's take out some of the products. It's not as easy to see now because it is starting to mix. Okay, let me see how fast I can do this. And it's hard for me to keep up with it. As soon as I take the water out, some of the water from the reactants beaker shifts in to raise the overall volume. So when I remove the products, the forward reaction happens, the reactants get used up and it makes more products. That's the part that's very, very useful in chemistry and in industry. You're going through a chemical reaction because you're trying to make something. Eventually, it will reach equilibrium and it will stop making your product. Well, if you can remove those products from the system, then the system will make more products for you. And that's one way that we can produce all of the different things that we produce. What happens if I add to the products? If you watch the reactant side, you can see that rising up. It's happening fairly quickly. Okay, so if I add products, we get the reverse reaction, and it shifts from the products towards the reactants. If you can keep this demonstration in mind, and always think about the reactants versus the products and what would happen if you removed one or if you added one, that should really help you in understanding what the consequences of a change in a system will be when you're trying to figure out Le Chatelier's principle. Thank you so much. I hope this helped.